an ecologist, and he was interested in the interactions. He was an urban ecologist, actually. And he was interested in looking at changes of patches in an agricultural urban setting over time. What's changing? So back then, think about it, 1939, no satellites up there yet. No aerial photography really, mass production. They just started getting aerial photography, black and white photography, and then he wanted to look at change over time. How do you do that? They took vellum, transparent paper, traced patches of all kinds of different agricultural fields. The next one, and they superimposed them and saw the differences and drove a very complicated process, time consuming. And that's what we do today with GIS, just like that. Put the data in, it does it for us in a second, what they worked for years on. And so that's the beginning really of landscape ecology. And as we go through, we're not going to go all the steps individually, but we see that many different disciplines contributed to that field of ecology. Partly ecosystems ecology, metapopulations. You've probably heard of island biogeography, McCart and Wilson, hierarchy theory, patch dynamics, species coexistence, and so on as we go down. These are the ecological disciplines that all contributed to what we know today as landscape or spatial ecology. And then we have computer and the digital world that also had to come along at the same time at different time steps. So in blue over here, you have computer science and related digital technologies. And it started all out with, first of all, we needed hardware, computers. Without computers, and so if you think back, it's not really that long ago that computers came around, right, for that kind of work. 1981, IBM, first one commercial computer pretty much. So that's within my lifetime, probably not within your lifetime, but there was a time in my life where we didn't know what a computer was at that time, right? So that's how fast it goes. Now what we have, everyone has a computer in their pockets, pretty much carrying around with them 24/7. Macintosh in 84. Then we have software that comes along, GIS software. The first one in 1960 already, quite some time ago. This is the Esri, when Esri was formed in 69, the software we're using. But like I said, many open source GIS software packages out there right now that we're going to use as well. Then GNSS. What's GNSS? Geographic navigation systems, satellite systems. Second S. First S stands for satellite systems. So the first one was NavSat. Which one is the one that you know and we all use, and we use interchangeably in name, is GPS. Right? Who has not heard of GPS? I think everyone has heard of GPS. So GPS is the American GNSS. And GNSS is the more common term. GPS was 1978, first one in the world, setting up satellites for global precisioning. And when I went to the field to Peru to do my master's in 2002, we still had the selective availability turned on, right? We had these relatively big units go out there, and they scrambled the signal on purpose to not be able to find yourself within more than 100-meter accuracy. So 100 meter, think like right now we have centimeter accuracy, right? 100 meter. That was only 2000, around 2000, up to about 2007, you couldn't get that precision. And that's why I say how fast technology moves and civilian use of these technologies take over, and the demand, pretty much what drives these decisions. Then later on we had, and GPS is still not that great. So GPS has about an accuracy of about 30 centimeters to 16 meters. GLONASS has 30 centimeters. Baidu, the Chinese, coming out in 2010 centimeters in the European system. In 2011, now you can actually get 1 centimeter accuracy civilian use right there. So you see, in a relatively short time, our accuracy increased so much. And many systems that we use today can use satellites from all of these systems. All right, so, and then remote sensing, another part where we now have so many satellites up there, Earth observing satellites, but we can constantly, every day, we get gigabytes of data about the surface, something scanning the surface of the Earth, sending the data down, being stored in all kinds of agencies around the world. We have more data these days, spatially explicit data, that we can ever analyze. So if you have great ideas of what's going on in the world that you can detect from space, aerial photography, whatever, write a proposal, you can get funding for it because there's so much data that they're collecting and they have to justify it's being collected, so they want you to use it so they can keep going. Anyway, so it started already in 1858. First aerial system was a Dove, a little camera mounted, and the first aerial observation system. Then later they used balloon photography. I think he was the most famous one at that time. And then the first satellite, Sputnik, Russian satellite in 1957. And the ones that you see most, you see in the US, the Landsat system. Landsat 1 through 8, number 9 going up soon. Multispectral sensors. We're going to look into that. We're going to have a few images, look at the numbers, look at the data, what we actually get, what it's collecting, and how all that looks. Because satellite data is our main source of raw data to make maps. Right? In the past, they walked everything, surveyed it, drew polygons. Today, we get a picture. All we need to do is delineate boundaries of things from the image, find algorithms, use algorithms to detect the patterns where we want to draw the boundaries. And that's what remote sensing is about. So you see that this whole thing comes together. It's ecology, biology, but it's also computer science and technology. You have to have a little bit of understanding of everything in order to see how it all comes together. And like I said, by the time we finish this class, there are probably another 25 satellites up there. Right now, we have over 150 Earth observing satellites that are daily sending data back. So now GIS. What is GIS and how do we use it? Well, very, very primitively put, it's just a model. We're trying to model the world. We have the real world, and we take that real world apart in its components, constituents, and we by theme, and then we put these different themes in different layers. We layer them, and by the spatial correlation of things that we see a point here, a point there, we can go through the data cube and say what is correlated with each other in space. If we have multiples of these through time, we can get a time series, and in space, correlated with other things in time and space. We drill through and we have a data point that is so rich now that we can do all kinds of analysis with it. Right? Think about going back in time. Like I said, everyone goes out and collects data on the ground. 100 data points in the Everglades. It takes about 3 months to walk out there and do that. A lot of these data points now we can measure remotely and then correlate with each other very fast. And so that's where the GIS comes in. How do we model the real world using all these different data sources? And the part of it, again, is the hardware, software data, but it also is the methods, spatial analysis, and the people. The people are the driving force. We have questions that we want answers to. We decide what gets collected, when and where. We decide how it's analyzed and how it's used in any kind of application, any discipline that we can think of. And so all of this starts out with usually a integration process, an integration process of the data sources, different data layers. They get integrated spatially, and they need to be stored somewhere. Where do they get stored? They get stored using hardware and software on hard drives, where then the software allows us to pull the data out, usually, and visualize it. And so that whole process, store it, edit it, analyze it, share it, display it, and that's the part of visualization. The important part at the end is how do we know what we analyze now in a spatially explicit framework to convey an idea to policymakers, to whoever, to a customer? How do we tell the customer, you should put another store over here, another Starbucks or whatever? Why do we need one? Well, you have all this customer data, you have all the coffee shops, you have socioeconomic data available in different layers. You do your analysis and say, well, it looks like over there's a spot where a coffee shop would do well. Hopefully it's not a Starbucks, but a local store opening up. So, but that's where the power of this spatial data come in, when you have the right tools to analyze them and visualize it. But the visualization is very important. So what I would like to do now is we're going to watch this little video here. And your first assignment will be to write one page, no more than one page, I say actually, 3 paragraphs, that you identify where in this video you can see yourself, reflect on questions that you have, interests that you have, and you're going to see it's going very fast, different disciplines, and then see what they're doing and how it seems like data, spatial data, are being used, so that you can say what your interest is, why that aspect is of interest to you, how the technology you think can help you in your answering your questions, and then what kind of project you would like to do in the class. So that's your first assignment, quick write-up. That's going to help us to identify interests and come together and work in groups on questions that we're going to try to answer by the end of the semester. Okay, so I'm going to watch it now, and there's the link. It's in your assignment as well, so you can watch it again later. And I hope this works. So.
We know we're interconnected. Part of a broader, ever more complex whole. It can inspire. It can overwhelm. It depends on how you see it. In confusion, you find connections. In complexity, understanding. You spot the pattern. See the big picture. What you do keeps it working. Moving. On time. You make it faster, smarter, better. You can answer. Is it safe? Are we ready? How do we help? You find the cause. See the options. Decide the solutions. You help us all work together to take better care, be healthier, happier, and do the right thing. You make a difference because you can see differently. You have the power to see what others can't.
All right. Quite a few areas in the world that work with GIS right in our daily world. There's almost nothing these days that does not work with spatial data. When you look at that. No matter where you go, there are databases that manage more than we think and want to know sometimes. At least in my case. So knowing about that, I thought it would be interesting for all of us to hear a little bit about it. So on Wednesday, what I want to do is want you to do a write-up. You can volunteer to talk about, we're too many for everyone to do it, or write a little thing that you can present from your write-up that relates to this, so we can all think back into these kind of different aspects. Okay, so it helps us to understand our interests here. Any questions?
How long should it be, the write-up?
How much?
How long should it be?
How long? Less than a page, 3 paragraphs. Yeah, and it's on the assignment. So all of you have used Canvas before? Yeah, so there's a Canvas page. The first assignment should be posted. Let's take a look at it. Sometimes I don't know how if it's popping up correctly, but is anyone on Canvas right now? Student view. Yeah, so I'm in the student view now, and I see the exercise 1 research interest statement, see what others can't. Right. So under assignments, this is what you see. So the syllabus is here. Everything that pretty much I mentioned that was in the presentation, you will find here. Book, final grade assignment, I didn't have that in the slide, but it's like, this is the grading, final grading. And then the schedule, which is the next thing I want to do real quick to go over, is the different subject areas that we're going to cover. So we're going to start today, we start with Intro to Landscape Ecology. We're going to do the first 2 weeks introduction to the software, getting to know spatial data, how spatial data are stored, and the format of them. And then a little bit of analysis, 2 exercises you're going to do in the first 2 weeks. Just exercises, ungraded, 1 graded. And then in weeks 3 and 4, we look at spatial temporal issues, risk analysis. That's where the epidemiology comes in a little bit, where we're going to do a risk assessment, incidence and risk of transmission of disease. Then we're going to get into landscape heterogeneity. How do we describe heterogeneity? How does heterogeneity again affect processes? And there will be an example, very well-known example actually, why space is important, why people realize that space structures communities. Pretty much all life is structured by space and time. That if you leave that out, you cannot explain most of the things happening, even though we sometimes try. So this is one we kind of get here with one example. Up to here, we use ArcGIS Pro only. Then we look into pattern analysis. We're looking at the Lycia hetaria, which is a moth species in England. We're going to look at the distribution patterns, what drives the distribution patterns and all that. And we're going to do that as an R exercise. The next one then is point pattern analysis, where we look into a Puntia cactus, and it's a pest on the cactus, so to speak. Their interactions, and we're going to look at point pattern analysis. How are the points relative on the landscape arranged? How do they affect each other, and so on. Then we look at the functional heterogeneity. That's the example that we looked at earlier today, where you saw the forest, green forest with dead trees. That's this example, where we're going to do reading and an exercise to that. And then connectivity, and that's a big one, where you're going to learn Python, looking at Python code. And we're going to look at Puma concolor, pumas, so mountain lions in California, looking at connectivity of habitats. How do we analyze the connectivity of the different habitats they use, and with the interaction of traffic in an urban setting, right? So how do you do a spatial analysis to see what is the most likely route they're taking? If you needed to put a preservation aspect, like a conservation aspect, how do you create, what do you call it, corridors for them to move across the landscape? Where would you put them? Like those kinds of questions you can address using GIS, and that's when we're going to get into Python and process modeling. And then the last one is the one that I hope we can get to. I'm not sure, but that would be a niche modeling, which would probably be interesting to you. You raised your hand in that one. I hope we can get to it. So that's pretty much the semester. Loaded. You're going to learn a lot technically. I don't know how computer savvy you all are. We will be after this. I can promise you that much. You're going to learn quite a bit on computer background, which I think is not a bad thing to have in any field these days. So, so that's it. And it's 3 o'clock. We're going to cut it a little short today, the content. But what I would like to do is each one of you just to introduce yourself real quick, where you are in your studies right now, and not so much about the research. We're going to do that on Wednesday. Yeah. So just we know where along you are, yeah, pretty much. So who wants to start? And I can get familiar before you start. I want to get familiar with faces and names. So let me pull up the list here. All right.
Do I start?
Yep.
Okay. Hi, everyone. My name is Kevin. I'm a pre-dental student and I'm a biology major here at FIU. This is my last semester here, and I will soon be in dental school. In a year from now, I have to take my entrance exam and apply to dental school.
All right.
Yeah.
We'll find an application for you here. Okay.
I'm Cynthia. I'm a senior. That's it.
What is it?
I'm a senior. Cynthia.
Senior? So you're also
Mhm.
going to be gone soon then?
Yeah, I just want to graduate.
All right. I hope this is the one that lets you do that. All right.
Hi, I'm Sebastian. I'm a pre-med bio also last semester, and I'm applying to med school this June. And yeah, hopefully MCAL works out.
Hi, I'm Hossein. I'm a bio major. I'm a senior also, second to last semester. I'm applying to med school next year, taking a gap year, and I work at a hospital.
My name's Richard. I'm a senior, a bio major, and I plan on doing dental as well.
My name is Lucas. I'm a grad student, and I'm trying to learn JS because I think it's going to be like Dr. Gann said, it's like it's all the field I'm trying to do. I'm going to like conservation, college and environment, all that kind of stuff. So, very relevant.
My name is Leo. I'm a bio major, and I'm a sophomore.
Okay.
My name is Sophia. I'm a marine biology major and I'm a sophomore.
Hey, hi, my name's Emily. I'm a bio major. I'm a senior in my last semester and I'm pre-PA.
My name is Mairi and I'm a sophomore and I'm also a bio major. And I'm Saili. That's my twin. So don't get confused. I'm also a biology major and I'm a sophomore.
Yeah, I'm gonna try to do my best. Don't do what I did with my brother, because I have a twin too, identical.
Oh.
Yes, and we swapped quite a bit in class.
I never do.
All right.
My name is Jonathan. It's my last semester. I'm a bio major, looking to do physical therapy afterwards.
Hi, my name is Moore. I'm a senior. I'm bio. I graduated this summer, taking my MCAT this Saturday, applying med school this summer.
Hi, I'm Nicole. I'm a junior. I'm a pre-med bio major.
My name is Emily. I'm also a senior. I'm pre-vet. I'm here by starting soon.
What was your name again?
Emily.
Emily.
Yes.
You signed on already? Oh, okay, I see, all the way at the top.
Am I there? Okay.
RC?
See, yeah.
Okay, all right, good, so I think we're complete. All right, now last thing before we leave, I want you to log onto the computers. First, tell me if you cannot log on. I'll tell you how in a second. You probably already can guess how. And then check. I'm going to pull that up again. Too technical.
Can we just search that up on the top of the Google Chrome?
Which one?
The link, the server that you put?
No. You're going to log on with. I'm trying to find the. So your username is your email address, and your your password is your Panther password or password. So you should be able to log on. If you're not, let me know. First thing you want to try is another computer. You in? Okay, you're all in. You in? Okay. Password is your Panther password. You know your password?
For what?
Your email. It's the same password for everything, right? Jesus Christ. Yeah, seems like you're all gonna be good. All right, it's the first semester ever, the past however many years that someone did not have access. Okay. Now make sure it's over here. Now check whether you have access to when you go to the Explorer. You know how to use the Explorer, the Windows Explorer. How many of you are Mac users? I should ask first. That's what I feared. I don't know how to use Mac. So when I speak, forgive me, it's all going to be PC language. But you're going to have to use PC language here anyways because we only work on it. And the software right now that we use does not actually work on Mac either. So having said that, yeah, we're going to work through it. The words that I use right now is for Windows. Microsoft is the Windows Explorer. What is that called in Mac?
Safari?
Yeah. Safari. That's a.
Safari is like Google for Mac.
Okay, Google Chrome. No, what I mean is the Windows Explorer, the file system, where you actually.
Oh, it's Finder.
Yeah. Finder. Okay, so Finder. Think Finder, and then so in my case, it's up here on the right. Just click there, and then you have access to your files, your whole folder system, file system, right? What you could see here is I have my OneDrive here, but then this PC is your local machine. For those of you who are not familiar with that, and this PC now has different access shortcuts, but the important part starts down here. C, like I mentioned earlier, is your local disk. That's the local disk where you have your operating system installed, Windows, users, profiles, and all that. That always sits here. The next one here is, in my case, Q, which is the public. Can everyone verify that you have access to Q? All right. Anyone who does not? Okay, good. So on Q, you can see here on PCB 4662C 2023-1 for spring, that's our folder. That's where the data will be posted, especially the stuff that's too big for Canvas. There's some files that I just cannot load onto Canvas. As you can see, those data files can be very heavy. Okay, so this is what we're going to share. The next one is you don't have the X drive, then the Y drive. Everyone has a Y drive? Good. And then the personal, in my case, it says Z. In your case, it should be S.
I don't have it.
Yeah, no S drive.
Yeah, I have.
Okay, who does not have an S drive? Okay, so for those of you who have it and those of you who don't have it, pay attention because there will be a day when you don't have it, even if you have it now. For some reason, they get disconnected sometimes, and if you go to different machines, that can happen. So I'm going to show you now here how you can map a drive. So when we say map the network drive, you right click on this PC. This PC, map network drive. and then this window should pop up. Right? Now the drive letter that you choose, it really doesn't matter. You can choose any letter that's open. But for consistency, when I give you code, it's gonna say replace the Z with an S. If you don't put an S right now, you're gonna have to always think what's yours, right? So put S if possible. S is your personal. And then the folder is where it goes now. That's what you were asking the server. Where the server name comes in, and then the share. The share is the folder, the top level of the folder that is shared. And from that point on, you're gonna have to then browse down deeper into the folder structure. So what's the server here? Anyone can tell me? For the S drive, anyone has the Canvas open? Look it up on Canvas, on the syllabus page.
Is it on your syllabus?
On the syllabus. So whenever you don't have access to any of these drives, you can reconnect to Q, S, and Y following these paths, okay? When that disappears, or if you want to map to them from your personal. So which one are we going to use?
The S.
S is dpanther FIO2, computer, that's the computer name, dot panther domain, subdomain, domain at fiu.edu, .fiu.edu. So this is the full domain, fully qualified domain name of the server. Students, $, and then / your username.
So this is if you don't have one, or
That's if you don't have one.
and if you do, it's fine.
It's fine, but just in case, like I said, if you go to another computer or you want to map from home, this is how you would do it. All
So
right.
we can map it to our computer, like my laptop.
Yep. You can map that drive to your laptop only if, let's say you're at home, you have to be logged onto VPN.
Okay.
You have to have an IP address. Everyone knows how VPN works? So, but you heard the name, probably the term, right? So VPN is virtual personal network. So what happens is when you have a provider at home, I don't know, AT&T, Xfinity, whatever, you have a hub that you connect your computer to, and it gives you a number, an IP address. Everyone heard about IP address? What's the IP address of your computer right now that you're working on? How would you know?
You go.
Huh?
You Google it and it tells you.
You can't? Can you Google?
Yeah, you can.
Yeah, what is my IP? That's right, there's an app. So let's just say we don't have Google. All right, so you can just say, you can put a CMD. CMD is command prompt. A command prompt is pretty much an interface that allows you to communicate with your computer at a very basic level. A command prompt. Again, Macs users probably have their counter name for this, and then you just type ipconfig -all. And then it tells you everything about your computer right now, the host name. So I'm working on GIS274 ints for the structure. That's my name. And the primary DNS suffix, so that's the domain and all that. And then down here, it tells you the IP address, 10.100.110.65. That's my IP address right now. So when you're home, AT&T or Xfinity, the box that you have, gives you a specific number for your network. Now, when you come to FIU and you're with your laptop and say, map my network drive here, they say no, because this IP address has no access to my server, to the server. It gets blocked. So when you do VPN, you log onto VPN, and your computer picks up an IP address that starts with 10.100. So it looks like as if your laptop was on campus, and it said, oh yeah, I can let you in because you're on campus. Even though you're sitting, I don't know, in Australia, it doesn't matter. Right, so the IP address is given for a domain without knowing where the computer physically is. It thinks that you're within the network, and therefore you have access. So that's how VPN works. Yeah, so when you go anywhere in the world and you want to have access to here, VPN, you have to use your username and password for the FIU VPN system. That's what authenticates you with your Duo. It gives you an IP address for campus, and now you have access as if you were sitting here on campus. All right, and that's not just for this class; that's for everything. So this is something they should teach you in the first semester you come here. I think would make many people's lives easier.
That's right.
Yeah. So two. You have to double.
I don't. And then my username is
Okay, so those of you who tried connect to S-Drive and didn't, I probably have to create a folder for you. These are generated automatically by Department of Information Technology, but they might have forgotten to create a folder for you.
I wasn't able to do it either.
Okay.
Yeah.
Send me an email. Those of you who cannot connect to their S-Drive, send me an email and I create the folder and share it with you. Okay?
Do you want us to email you through like regular email or can?
Doesn't matter. I always get it in my regular inbox. All right. Good. Any questions from your side? No? All right. We'll see you on Wednesday. Okay, there's a question. Yes.
Yeah, sorry. It says that the assignment for the essay is due in next Wednesday. Is that right, or is it due this Wednesday?
Did I say next Wednesday? I usually give long time to.
Yeah, it's the 18th.
Yeah, so then that's when it's due. But like I said, I would like you to think about it, and we're gonna start talking about projects this coming Wednesday.
Yeah.
Next Monday, we're gonna be off. So, yeah, try this week, but it's due on that day.
Yeah.
Any other question? All right then. See you all on Wednesday.
How does someone like